Coming seemingly out of nowhere and storming straight into the spot of 6th highest market cap, the Internet Computer is a project that not many people outside of developers really actually know about. But the thing is that ICP could actually revolutionize the way that the web works, so stick around and let's talk about it. Hey guys, I'm Sprag, and you could be forgiven for not having heard of ICP before. Without much marketing and fanfare, it kind of just slipped onto the scene and only really started to gain media attention when it suddenly appeared on the front page of CoinMarketCap. But those who've been following the Internet Computer, or as it was previously known, Dfinity, will know just how ambitious the goals of the project are in how it wants to change the way the web works. The Internet Computer, which has been in the works by the Dfinity Foundation, has been around since 2018, with 5 major stages to its development cycle. The final of these stages was called Mercury, which marked the mainnet launch of the Internet Computer. Now, despite the name sounding like something straight out the 90s, the Internet Computer is actually aiming to do something that us developers have been wanting for years: a complete overhaul of the completely outdated tech stack that the internet currently runs on. Also, just a quick side note here, if you enjoy my content, please do consider subscribing. The big problem lies in the fact that the new infrastructure for the web is just built directly on top of the old infrastructure for the web, which means that we are now sitting on a $3.6 trillion legacy tech stack. This isn't at all helped by the rate of adoption that happens when it comes to anything to do with networking and the internet. For example, the IP address, as you might know it, the IPv4, which is 4 numbers separated by 3 dots, ran out years ago, with every single one of them now being owned by ISPs or hosting providers. To get around this, IPv6 was created, which uses hex and longer groupings and more groupings to create what is essentially an endless supply of IP addresses. To put this into perspective, there are 3.4 times 10 to the 38 IPv6 addresses, compared to a measly 4 billion IPv4. The problem is that many view IPv6 to be over-engineered and overcomplicated, which means the rate of adoption, despite it being created in 1995, has been incredibly slow. There are still some ISPs that don't actually offer it to their customers. I'm looking at you, Vodafone. But you might be thinking, what does a difference in IP address actually matter, and why is it such a big deal? When I rented my server to run the site that is currently down below in the description, redirecting all of my affiliate links, I was given over 1 billion IPv6 addresses for free. Now, after days of trying to figure out how to set up virtual machines on my server using only IPv6, I eventually figured it out. This took me so long because not only is the real world adoption of IPv6 so bad, there's also so few guides on how to get it set up that it just took me exponentially longer to get it configured. Then, after all of this hassle getting it set up, I launched it, only to find out that a lot of ISPs still don't offer IPv6 to their customers and therefore cannot access my site. So instead of being able to use the billion free IPv6s that I was given for this exact purpose, I am forced to pay an extra $4 per month on top of my server cost just for 2 IPv4 addresses. And this should give you an idea of just how reluctant people are to adopt new technologies on the web. A protocol developed 25 years ago to solve an issue that is still plaguing the web more so every single year has got such a low adoption rate that the free ones I was given are basically useless. And on top of this, an even more worrying statistic about how the web works shows that AWS, Azure, and Google Cloud have 56% of the internet hosted on them. That means that if these 3 companies were to at any point just disappear, 56% of the internet would go with them. And this monopolization and reluctance to do anything which might better the web is exactly what the Internet Computer aims to solve. To achieve this overhaul of the web as we know it, data centers, instead of renting their server space direct to a customer, they would instead offer up their servers to be part of the Internet Computer. With the protocol being touted as hack-proof, this means that the owners of the servers actually cannot access the code that is running upon their box, which means any hardware exploitations cannot be used to break into the code running on them. This also provides great resilience to servers going offline, because if that happens, the code running can just be moved to another box with 0 downtime. Now, there are some real all-star teams out there in the crypto realm. However, I don't think any of them can hold a candle to Dfinity. which boasts 3 different research facilities in Palo Alto, Zug, and San Francisco, and over 180 of the world's most distinguished distributed computing experts, cryptographers, and sysops experts all working together to revolutionize the way that the web works. But that is enough preamble, it's time to dive into the thing I enjoy the most, the tech and the fundamentals. Getting a bit of deja vu from my last video, the internet computer claims to have once again solved the blockchain trilemma, utilizing the speed of every server in its network to achieve near web speeds. As I mentioned earlier, the current iteration of the internet uses IP addresses, and while it might be easy to assume that these are just differences in the number of digits in the address, they are actually completely different internet protocols, with Internet Protocol version 4 and Internet Protocol version 6. This is why IPv6 customers cannot access IPv4 and vice versa. IP, or Internet Protocol, is a set of rules that defines exactly how data should be sent over a local network or the internet, with the addresses just being the identifier for what endpoint is requesting or sending data. Dfinity aims to introduce a new version of IP, which they are naming ICP, the Internet Computer Protocol, which aims to completely change up the way the Internet Protocol works. Whereas the current version of IP only dictates how data should be transferred across a network, the new version, ICP, also dictates how the software platforms themselves should be transferred across the network. This would provide true mobility and scalability to any application running on ICP, because not only can the data now be transferred anywhere, the code it's running on can also be transferred anywhere, allowing it to essentially move from computer to computer to scale up to the size that it needs to be to accommodate for its user base. Whereas in the past, data centers would get their money from renting the servers directly out to users, now instead data centers would be paid in ICP tokens for the computing power that their servers are providing to the network. However, due to them not having any access to the data that is running on ICP on their servers, it means that they are unable to collect data and sell it on to third parties, meaning that ICP is far better for the consumer because the server owners cannot see what is going on within the servers. So why are developers so excited about this concept? Because really, at the end of the day, it's still just code running on a server somewhere. Well, essentially, the internet computer allows developers to containerize their application and launch it onto a platform which is infinitely scalable and will always provide their program with 100% uptime and the resources it needs to cater to its specific user base. This means that not just websites, but enterprise systems, smart contracts, and DeFi platforms can all coexist in the same space, while also being given the resources they need to grow effectively. This is especially pertinent when you take what happened the other day with the market correction, where most of the exchanges actually buckled under the weight of all of the users that were trying to flood on to either buy or sell. This is exactly what the internet computer aims to solve, and also to reduce the monopolization of the web currently. It's just better for everyone. Now, to understand how the internet computer actually achieves all of this, you need to know about its 4 core components: the network nervous system, subnets, neurons, and cycles. The network nervous system is the software that controls and governs the entirety of the internet computer completely autonomously. It runs as a part of the network and is integral to keeping the system going by interconnecting nodes or servers on the network, allowing it to run completely autonomously without the need for manual intervention. And on the side of how software containers or canisters can be run on the internet computer, this is also the network nervous system's job by creating subnets, but I'll cover that in a sec. The NNS is effectively the layer 1 blockchain of the internet computer, holding a public key that can validate all ICP transactions. It's also in charge of proposing any changes that might need to be made to the network. These changes could be things such as expanding the network, adding new nodes, or more substantial alterations to the network. These can then all be voted on by people who have decided to lock their ICP to gain voting rights. As I mentioned, the actual functionality of the network relies on subnets, which actually don't work too dissimilarly to how subnets work on the traditional internet. Subnets on the current internet work by grouping together endpoints by location to allow a faster transfer of data between 2 endpoints that might be closer together. This means that it can reduce the number of routers or switches the data has to pass through to get from endpoint A to endpoint B. For example, if you have 2 IP addresses within the same data center, it's much faster to transfer it internally than it is to send it out to a router somewhere halfway around the world and then back again. On the internet computer, instead of subnets just being a way of grouping endpoints, each subnet is its own blockchain. And on these blockchains, developers can then run canisters. These canisters are effectively just advanced smart contracts that create a way for a developer to run any sort of external code on the internet computer. Now, despite each subnet being its own blockchain, there is complete interoperability between all subnets, meaning that a canister running on one subnet can communicate with a canister running on a completely different subnet on the network. This is because of the fact that the servers hosting the canisters are effectively the nodes that are keeping the network decentralized. So because of this, the protocol can make sure that these canisters are distributed fairly across the network to increase decentralization. This is a stark contrast to a lot of other proof of stake and proof of work systems, where there is a reliance on humans to make sure that they are keeping the network decentralized. For example, in most nominated or delegated proof of stake chains, there is a requirement that the chain needs to disincentivize or incentivize the decentralization of its participants. In my opinion, the fact that running a node and selling your server computational power and storage are the same thing gives this chain a massive leg up on the competition. But the fact that instead it allows data centers to monetize their servers as they would be doing anyway, while also increasing the decentralization of the network, means that they've effectively cut out the number one thing that causes problems for all other blockchains: humans. The next component we have is neurons. Neurons are effectively a way of time locking ICP to allow voting on the network. But the thing is, they're not just a way of saying yes or no to a vote. Neurons are smart enough to be automated in the fact they can follow the voting patterns of other neurons. For example, you can have one neuron that follows the voting pattern of another, that follows the voting pattern of another. This effectively means that you can have a liquid democracy where neurons are acting on the decisions of other neurons. The other function of neurons is to release locked ICP to turn cycles into computational power, which brings us on to the final component: cycles. Cycles are consumed by the software canisters to allow the persistent storage of data, bandwidth, or computational resources. Each software canister will keep a track of the resources that it is used on the network and represent it as a unit of cycles. Due to the fact that these software canisters keep an exact measure of how much resources the software inside them is using, it means that an extremely well optimized application will actually cost the developer far less money. This means that developers are actually very actively rewarded for streamlining their application to the point where it uses as little resources as possible. And in doing so, this will invariably have a good effect on user experience, benefiting everyone. Alongside this, because a developer will know how many cycles his or her application is using within a canister, they can then limit the usage of cycles, which means that if an exploit is found and any malicious code starts being run within their canister, they can quickly shut it down before it actually causes any damage. And as one final benefit to all of this, developers will actually be able to quantify exactly how much each of their applications is costing to run. For example, my server cost me $44 a month, but I have no idea what the actual breakdown of each of the apps on there is. And the thing is as well, that I technically don't need that full amount of server space for the number of apps I'm running. It's purely for a data compliancy thing. So I would love a way to containerize my apps and only pay for exactly how much each one is worth. And the thing is, the internet computer isn't just forward thinking. This is already being adopted, with 48 data centers and over 1,200 nodes already on the network. Dfinity are planning on upping that number to at least 120 data centers and over 4,000 nodes by the end of the year. As someone who is constantly whipping together websites, scripts, and applications that I just chuck on my server, I really do hope that this becomes the way that the internet works. The idea of being able to containerize my application, chuck it up, and not have to worry about any of the trials and tribulations that come from server security or just hosting a public-facing application in the first place would be amazing. And the thing is, with the team that it's got and the vision that it's got, I genuinely believe this could make a huge difference and be the thing that changes the internet. However, if you've made it this far, you will know this is normally the point in the video where I talk about my concerns. and I have a big one. Because of the way the internet works right now, if I put something illegal up onto my hosting provider and they get a report that it's illegal, they will take me offline straight away. However, on a decentralized network, this is left up to a vote amongst the community. Now, this does mean that if any illegal content is uploaded, it will be taken offline as soon as a vote is passed to do so. But who's held accountable? The problem is that the app developer can remain effectively anonymous as far as they want to, and because the server providers don't actually have any knowledge of what data is running on their site, who do you hold accountable for the illegal content? For example, you can't shut down a phishing attempt if you cannot find out who is putting the websites up. And because of the fact that there is no step, as there currently is on the web, of creating and buying a host and signing yourself up and putting some identifying details in, someone who wanted to host a phishing website could create their application, put it in a canister, and just keep uploading it, and every time it gets taken down, put it back up, and there really wouldn't be anything to stop them. Now, while I think that in the future this will be solved and a preventative measure will be put in place, I think that currently this is the biggest issue plaguing ICP, because the problem is that governments aren't going to allow an internet that lets anybody do anything completely unaccountably. Which leads me on to my second, slightly more minor point, is the rate of adoption of the internet computer. Now, I know that Dfinity have put measures in place to make sure that the internet computer and the current internet can coexist alongside each other by using REST requests to be able to make calls to inside the internet computer from outside. The problem is that, as I mentioned at the start, the rate of adoption on the net is so slow that I would really like to see where this goes further down the line in terms of actually one replacing the other, because at the moment, two of them working alongside is just going to add added complexity and might not actually make things better. I hope you guys enjoyed this video. I really actually enjoyed making this one. This is a great project and I'm super excited to see where it goes in the future. So this is probably one that I will follow up on in about a year or so just to see where it's got to. If you did enjoy the content, please leave me a like and a comment down below, and please do consider subscribing. Thanks, bye.